This is the 2014 Relative Velocity Question 2b. A ship B at noon is 300 kilometers south of ship A. Ship A and B, just do a little sketch. 300 kilometers. Ship A is traveling southwest. Southwest will be in this direction. And we have its speed here 24 root 2. 24 root 2, and we have an angle of 45. And the velocity of B when it's traveling due west at 31 kilometers an hour. Due west. And in part 1 we're asked for the magnitude and direction of the velocity of B relative to A. So let's look at the velocity of B first. Velocity of B is in the minus I direction, minus 31 in the I direction, plus 0 in the J direction. The velocity of A, it's going down in this direction. It's going to end up in the negative sector. So it's going to be minus 24 root 2. And the I component is opposite the 45 here. So it's going to be sine 45. And I know the sine and cos are the same here, but just get them right. Minus 24 root 2 by the cos of 45 for the J component. The root 1 over root 2 for the sine and cos of 45. So we just get minus 24 in the I direction, minus 24 in the J direction for the velocity of A. So the velocity of B relative to A is the velocity of B minus the velocity of A. So we get minus 31 minus 24, which is plus 24. So we get minus 7 in the I direction. And we get 0 minus 24 plus 24 in the J direction, and the magnitude of this works out evenly to be 25. It's a B and an A. The square root of 7 squared plus 24 squared. If you're getting to this and have never seen that, well, I'm not sure that's possible. Kilometers an hour, and then this angle, the angle theta, is equal to the inverse tan of 24 over 7, which gives 73.74 degrees. Then we're told that they can exchange signals when they're within d kilometers of another, and if they can exchange signals for 2.8 hours, find the value of d. So a sketch would help here. So the velocity of B relative to A, we have A and B, A above B, A and B. Velocity of B relative to A is minus plus, so in this direction. So I have my shortest distance here, and the velocity of B relative to A. So if I give it an x-axis, the angle that we got is here. This is theta, so this angle here is going to be 90 minus 73.74. which is going to be 16.26 degrees, and A to B was 300, wasn't it? 300. So we have our diagram here, so just let's reread the question. They can exchange signals for 2.8 hours, find the value of D. Okay, so let's say they can exchange, I'll change color here. Let's say they can exchange signals between these 2 points. We call this point X. We can get AX with our angle inside the triangle, so I'll just take the triangle outside here. With the hypotenuse of 300. With this angle in here is this 16.26. So we can say the sine, I'll call this Y for now, the sine of 16.26 is equal to Y over 300, so bring your 300 in front. And that will give us Y. So the shortest distance between them is going to be, gives 83.998, I'll round it off to 84 kilometers. So now if we imagine the velocity of A relative to B along this line here is 25 kilometers an hour. So in this section 2.8 hours, it's going to be 1.4 hours in each of these two sections. So 1.4 by 25 will give me the distance traveled along that bottom bit. So that's going to be 25 and 10, 35 kilometers. So then we have our right angle triangle, and we just need the diagonal to get the distance d. This d here, we have y to be 84, 35 kilometers along the bottom, so d is the square root of 84 squared plus 35 squared. If I divide both of them by 7, I'd have a 12 and a 5, which would mean my 13. So 7 by 13, this should give me 91 kilometers.